Okay, so I'm going to record a solution of number 7. So 1, you have the solution, and 2, you can kind of see how a video presentation should look. Okay, so as a reminder, if you have red numbers in your problem, they're going to be different student to student. Some students may have the same ones, but they're randomized. Some may have different ones. So realize the answer that I produce here might not be the correct answer for your given red numbers, but the process is the same, so you should be able to re-execute the process and develop your own understanding of what's going on along the way. So if you read the problem, it's pretty short. Children between ages 6 and 10 have a height that is frequently a linear function of age t. And then they give me some extra information about the height of the child is 45 inches at age 6 and 47.5 inches at age 7. Okay, so when reading that, I saw this keyword linear. So if I think about what is this problem really about? It's about making the equation of a line. Okay, so I know y equals mx plus b is slope-intercept form of a line. But if I read more about what kind of notation they want me to use, they don't want me to use x, they want me to use t time. Okay, so you could prevent yourself from kind of losing silly errors if you read those directions very carefully. They're saying the age t. Okay, so that means t is my input, and the height is going to be my output. So y is a function of t. There's a lot of extra numbers given, but the second sentence here says, at age 6, the child is 45 inches tall. So when the input is 6 years, the output is 45 inches. Also, when the input is 7 years, the output is 47.5 inches. So with these two ordered pairs, knowing that I want to make a line, I'm going to jump right to slope. So y2 minus y1 over x2 minus x1. They're not x's, they're t's, but I can still use that same slope formula, which really changing outputs over changing inputs. Numerator is going to be 2.5. Denominator is 1. So I can either write this over 1, or I can just think about this as the number 2.5. If I prefer a fraction, this might be handy later, when I'm trying to interpret the slope. 2.5 as a decimal is the same thing as 5 halves. Okay, so I have this slope now. So y equals 2.5t. Nothing given to me tells me my y-intercept. I would have a y-intercept if one of these input values was 0, but they're not. So instead, I'm going to have to plug in this specific point. T of 6, y of 45. I could also use this one, but I see this has like a decimal here, so maybe I don't want to use that one because the arithmetic could be more challenging. So if I start plugging in a t of 6, a y of 45, I can now solve for b. 6 times 2.5 is 15. Subtract b from both sides. Now I know my y-intercept and I have everything I need to get the first part. There's the linear function using a t. It also asks me to sketch this line. Okay, so I'll just do the quick sketch down here. I know my slope, or my slope is 2.5, which is 5 halves. My y-intercept is 30. So this is just a really rough sketch. So that's number 30. As a y-intercept, it is the point 0, 30. Now I have a slope of 5 halves. So here's where the fraction part could be more helpful. I'm going to go rise 5, run 2. So if I go up 5 over 2 from being here, the over 2 part means I am now at an input value of 2. And the rise 5 part means I'm now at an output value of 35. So with those 2 points, I could just connect the dots, and there is my sketch of my line. If I'm interpreting the slope, just moving on through the parts of the problem, I'm going to come back up here where I calculated the slope and think, okay, my output was height in inches. My input, right, if I do change in y over change in x, the input's down here, is years, time in years. So my interpretation is that a child is growing at a rate, slopes are rates, of 5 inches every 2 years, or that's equivalent to 2.5 inches every 1 year. They all mean the same thing. Last part is this part C. So here's part B over here, here's part A right there. Part C asks you to predict the height of the child at age 10. So this is a nice way we can use functions. We can make predictions of future values. So in part A, I have my function, and it's asking, okay, when the age is 10, when the input is 10, what is the output, the height? 10 times 2.5 is 25, plus the y-intercept of 30, 55 inches tall. Okay, think about what this says. What this is saying is if the child is growing 2.5 inches every year, they're doing that for 10 years, and then you're just going to add like your initial value to that. Okay, so we have all the parts of the problem as a summary. This was about lines. You need to know slope-intercept form, calculate the slope, be able to graph, and just to interpret what the last part was asking with the prediction. Okay, if you've got questions, just post them in the comments. Okay, good luck. Bye.